Okay. Can you see the screen right now?
We can, yes.
Okay, thank you. All right, so we already go through the syllabus last week, so I will start with lab one. So okay, before we talk about the lab one, I will mention this in tomorrow class. Okay, so there are some useful information for students. Most of them are already posted on Brightspace, like the AD2 tutorial, uh, like the DMM tutorial. Some of them are in the course website, like the guideline for the breadboard and the guideline for the resistor capacitor reading. I think I will also post this on the Brightspace later today. Okay, and also for each lab, there is a pre-lab video, or there's a video for the experiments introduction. And also for lab one, we will give a template. We don't have template for AD2 version, so this one is just for a reference. Okay, they will make their own template in the future. It's just confirm Wispen, is that the idea we are going to do?
Yep, that's the plan. So in future summers, it's going to continue online. So by next summer, we'll have templates that will go with them.
Okay. Okay, then last one is the office hour. Try to cover the office hour like all day, since probably students are in different time zone right now. So if you prefer early morning, you can do early morning. If you prefer later night, I think you can do later night.
If you haven't yet, please make sure you put your hours on the calendar. I'm still waiting on quite a few of you. But again, please make sure we're trying to stretch that out as much throughout the business day as possible. It looks like we're doing all right in regards to spreading out, which is good. It looks like we could use a few more office hours on Tuesday and Thursday. Monday, Wednesday, and Friday are looking okay for now. But again, the more you're willing to do and the more you're willing to spread out, the better it will be for everyone involved. So please make sure you do that as soon as possible.
Okay. Yeah, and another thing is for the LT specs. I think we don't have like a tutorial made by ourselves, but they can easily find the tutorial online. And we had trouble for the Mac version. For the okay, no, that's IoT space. No, that's yeah, that's IoT space. I think one way they can do this, I saw some students use remote to connect with the school's computer, so they can use the Windows version. But we will see will we have this trouble in the class. In the lab one, they will use LT Spice, since I think probably some students will not get their AD2 or lab kits for tomorrow class.
I
All right.
have confirmation from shipping and from Electronics Express that everything has been shipped out that we've
Okay.
provided so far. So as long as they ordered it and told us that they need an 82, it'll be getting shipped to them hopefully by tomorrow. If not, it will be by the end of the week. So the first week they might have to, or the first up to lab 1 and 2, they might have to do the LT Spice. But after that, everyone should have their stuff that they need.
Okay. All right. Okay, for the lab one. I think still for lab first field lab we will provide the menu, but after that I think they need to use their purchased menu, right? Right. So yeah, so first lab is the kind of like an introduction lab. So I think you're all familiar with this. I will talk a little bit about this on tomorrow's class, at the beginning of tomorrow class. There are a couple equations they need to pay attention. The first one is the Ohm's law. Okay, they probably want to remember that equation. And then the power equation, okay, they will use these two equations over the whole semester. And the another thing they need to pay attention is the current and voltage measurement. Okay, so and that's also a common mistake. Okay, for the voltage measurement, they need to connect with parallel. Yeah, voltage measurement with parallel. Current measurement with series. Okay. But I think for lab 1, since they are going to use AD2 and also the LT spice, probably that's not a trouble for lab 1. But lab 2, they will have trouble with current and voltage measurement. Okay, so since the first lab it should be easy, so I will just jump into the tasks. So task 1, okay, is DC voltage measurement by DMM or AD2. I think they can use AD2 to measure voltage measurement also. Oh, by the way, it's just make sure is that anyone haven't used AD2 before, or all of you know AD2? Okay. Yeah, I will assume most of you know AD2. Okay, if you have trouble with AD2, you can let me know. Right. Okay, so task 1, step 1 is use the AD2 to generate a 3-volt and negative 3-volt DC and measure with DMM. Or if they don't have DMM, they can use AD2 to measure it also. And step number 2 is a little bit tricky question. They need to generate a 7-volt DC power supply, but the AD2 maximum power supply is 5 volts. So they need to know the voltage is the potential difference. Okay, so they can have like +3 and -4 volt. Okay, so that's 7-volt difference. So to generate a 7-volt measurement. Okay. And step 3 is easy. Step 4, they just use Ohm's law to do the calculation. Okay, so step 5, they just need to draw the circuit diagram. Or let's see. Okay, yeah, I think task 1 should be pretty simple. Okay, task 2 and task 3 is the LT spice. Okay, so they are going to use LT spice to build this circuit and do some simulation and verify the Ohm's law. Okay, so also I'm not going to talk too much here. Please make sure you like check step by step by yourself so you know what they're going to do in the class. One thing I need to mention here is probably this way is a little bit easier to check my note. Step number step number yeah, step number 5, they need to adjust DC supply to have from 0 to 5 volt with reasonable step size. Since they are using LT spice, so it's a quick simulation process. So try to let them sweep at least 10 points. Okay, so they are going to, that's a reasonable step size. And also step number 7, okay, they need to plot the Ivy relationship. So basically it's like a Ivy curve. They are going to get a very linear shape straight line. So that's where they can verify Ohm's law. But one thing they need to pay attention is the IV curve. Usually we put x-axis as voltage, y-axis as current. Okay, so that's not the only IV curve in this semester. In later on, they will also plot IV curve. So make sure they know they always put voltage at y-axis. I mean voltage at axis, y-axis as current, and make sure they need to label them. Okay, label the current and voltage, and also the unit. Okay, then the step, task number 3 is kind of similar with task 2. They just need to change the sweeping instead of sweeping voltage. Instead, task number 3, they are going to sweep in the resistor value right here, and they will plot the IV curve again. No, I think they are going to plot the relationship between current and the resistor. Okay, so I think they will get a different plot. It's not a linear plot, but that's because of the Ohm's law. I think that's all the task for lab 1. Okay, there are few common mistake for lab 1. First one is the current measurement. Okay, so they will definitely get mess up for current measurement for lab 1, but I think in this semester they are going to use LT-Spice, so it's not an issue for lab 1, but that will be an issue for lab 2. And then the percentage error. Okay, so they're already given the equation in here, so they should be fine for the percentage error calculation, but still probably few students will get negative results. So just make sure you tell them the percentage error should be always positive, since they are going to use the absolute value. Okay. And another common mistake is the IV curve. Okay, so as I mentioned, XY axis is voltage and current, and also make sure they label the plot. Okay, I think that's all for lab 1. Any question for lab 1 right now? This one should be a simple lab. For lab 1, the lab itself is not hard, but they need to learn how to use AD2, and also they need to learn how to use LT-Spice. I will let them to watch the AD2 tutorial probably before the class or after the class, and I will also talk about the how to use AD2 really quick at the class. Okay. Any question about lab 1? Okay. All right. Then let's talk about lab 2 really quick. Okay, so lab 2 is on this Thursday. Okay, so lab 2, they're going to study about AC signal. Okay, we have a PPT here. Oh, by the way, but I think since summer, some equipment is a little bit different, so I will still use your PPT, but I will take some of your slides, but not all of them.
That's fine. Yeah, the thing is, it would still be good for them to know about the function generator,
Okay.
oscilloscope, power
Okay.
supply, multimeter, that kind of stuff, because that's frankly what's expected to be used in future classes and in industry, right? They're not going to have an
Yeah.
82 to use when they go out, and if they have a job somewhere, they're not going to be wanting, or their employers aren't going to want them to be using the 82. So at least
Okay.
having an idea of what a function generator and oscilloscope looks like will be at least a little bit helpful there.
Okay. Probably then I will still talk about how the benchtop equipment work at the beginning of the class.
Sure.
Okay. So Yeah, lab 2 is about AC signal and also RMS value. You should all familiar with this. But just make sure you probably want to reveal the RMS equation. Okay, so the DC RMS is equal to the square root of AC square plus offset square. Here is average. Average is equal to offset for this semester at least. And here is AC RMS value, calculation equation. Okay, sine wave, they need to use amplitude divided by square root of 2, and the triangle wave is square of 3. Okay. Okay, I think that's it for the lab itself. Yeah, since we are going to use AD2, there is no Skype for the tasks. Okay, let's jump into the tasks. By the way, start with lab 2, they are going to have pre-lab. Okay, so yeah. Okay, so for the first one, is pretty simple. They are going to use the function generator or the function generator in AD2 to generate two sine wave, one sine wave and one triangle wave, and also then measure it with DMM or DMM in AD2. Okay, so in lab 2, okay, task 1, there, what they will get is if they have the handhold DMM, they are going to measure ACRMS. If they have AD2, okay, AD2 will give both value, the ACRMS and also DCRMS. Okay, yeah. Okay, one common mistake for the task 1 is the amplitude. Okay, so they will mess up with amplitude and VPP. Okay, so make sure you know that's a common mistake. Okay, so VPP is half of amplitude. Okay, I will also mention this in the class. I will use this plot for the class discussion at the beginning. Okay, let's say task 2. All right, so task 2, they're going to build the similar circuit with lab 1, but they're going to use AC voltage source. Okay, and still they're going to verify Ohm's law. Okay, I think in here that's the first time they're going to measure the voltage and current in the real circuit. Okay, so for the voltage, they can use AD2 to measure it. For the current, they can use DMM. I think one thing probably you want to know is I think DMM is option to buy, so probably some students don't have DMM. I think one way we can do this is they measure the voltage by AD2 and then just use Ohm's law to calculate the current in case they don't have DMM. But do you think that's okay for this?
A good number of them should be ordering the multimeter. Based
Okay.
on the order I got from Electronics Express, it sounds like the majority of them will have one. So.
Okay. Okay, then that sounds cool. Okay, hopefully they have both AD2 and DMM, then they can measure both of them at the same time. So yeah, common mistake, measure current. They will put parallel when they measure current, and then in that case, they probably will burn the fuse in their DMM. I think when they buy the DMM, they only have 2 or 1 fuse extra fuse. So if they burn all of them, they need to buy it by themselves, I guess. So I will emphasize this again in the class, but just make sure you know that's a common mistake when they measure current. Okay. All right, so then in the step number 4, they're going to plot IV curve again. So the Ohm's law still holds for AC voltage source. All right, then the task number 3, they're going to build the this 3 circuit diagram. So that's probably the first time they're going to build the circuit in breadboard. Okay, so they will have trouble with circuit building, and I think since this semester is all online, so it's a little bit hard for us to troubleshooting their circuit since we can only see the picture. So, but hopefully that will work out. Okay, so as I mentioned, this is the first time they're going to build the circuit, so they will have trouble with breadboard. But they will, I think they will get it after first few labs. Right, so just one thing we need to know is this task will require the 5-volt adapter to connect with their AD2, since I think for first 2 diagram is fine, but for the figure 2.9 they will get they will not have enough current if they connect with their laptop. So they need the adapter since everything is in parallel. All right, so step number 1, they just build the circuit and apply 5-volt DC to the circuit, and they can measure the voltage by DMM for each light bulb. And let's see. But then in step number E, they can calculate the power for each lab. Let's see, voltage. Yeah, I mean the voltage and current. They can measure voltage and current for each light bulb. Then they can calculate the power. But in previous semester, I think we dropped the step number D, the photoresistor one, since the number is very consistent for each student. Do you still want to do that, or?
No, we're not going to do that.
Okay. Okay.
That gets a little hairy and doesn't end up with the best calculations.
Okay. Okay, then you mean we are going to drop it, or we are not going to drop it?
Yeah, go ahead and just drop that. We can still calculate the light bulb's average or power using the current coming out.
Okay. Okay, yeah, we will drop step D here, so they don't worry about the photoresistor. And also this one, they also need to do the current measurement. They will get more confused compared with task number 2, since the current measurement method is different. I mean, method is still same with task 2, but in task 3, they need to measure the current for different bulb. Okay, so especially for, let's say, figure 2.8 and figure 2.9. Okay, they need to, let me find up here. They need to put their ammeter. Okay, so this is a, okay, that's not good drawing, but I think you know the idea. They need to put their ammeter right before or right after their, let me find up very quick.
One important thing to remember with these light bulbs is they're not ohmic. You'll actually find that the resistance of the light bulb changes as you add more voltage, which is kind of annoying. So you're going to find the power ratings are going to be kind of weird. They're not going to be a linear system like you'd expect. that's going to cause a little bit of confusion with the students. So just make sure you're aware of that and making sure you can kind of explain that if they ask about that.
Okay, yeah, so that's a confused part. They need to put their ammeter right here. Okay, some student probably they put the ammeter over here. So that's not the current for each light bulb. Okay, so make sure they put ammeter either right here or right after the light bulb. Okay, so yeah, you will see the question about this. Okay, they will confuse about current measurement. All right, so I think the question number 2 and number 3 is just they just need to answer the question. Okay. The power distribution one is the figure 2.9. Okay. They can have okay, they will have different reason for this. Okay, they can say like one, for example, if one light bulb is broken, other two still work, or in this case, the voltage is consistent for each light bulb. Okay, either answer is fine as long as they have a reasonable answer for this. Okay. Okay, I think that's all for lab 2. Any question for lab 2? Okay. Okay, so there are also some common mistakes for lab 2. Okay, first one is RMS value calculation. Okay, they will mess up or mix up the AC and DC RMS value. And also this is a small mistake, but some students always forgot this amplitude is half of VPP. Okay. And then the big thing for lab 2 is the current measurement and circuit building. Okay, so that's the first time they're going to build circuit on breadboard. So they need to learn how breadboard work. And also the first time to do the current measurement, they probably will, some students probably will burn fuse. I'm not sure since they're using AD2 not going to provide a lot of current, so probably they will be fine. If their current is very high, they will have a current overflow warning on the software. So that's probably kind of protect their EMF. Okay. All right, I think that's all for lab 1, lab 2. So each week I will talk 2 labs for that week. Okay, any questions? Okay, and I think we will start our office hour tomorrow. I think since tomorrow is lab 1, so if you have office hour tomorrow, you can start to hold your office hour. Anything else, Ben or Yi, you want to add on?
I think I'm good for now.
I'm good. Any questions, concerns?
I have a question about office hour for today. So I think I've scheduled for an office hour today. But should I just cancel that since since the lab starts tomorrow?
Yeah, you're welcome to cancel it. We're probably I didn't have anyone show up in mind. I'm sure I'm willing, but we're not gonna have any office hours happen today. We don't have anything to do office hours on. So
Okay.
I can
Okay.
cancel that. Yep.
Okay.
Was everyone able to either get a meeting scheduled with engineering to get your I-9 verification or are already verified? I just want to make sure we're getting that cleared up. Are we good there?
They've not responded to me yet about establishing an appointment.
I did send them an email saying you needed a virtual one, so hopefully they'll get back to me soon.
Yeah, I went through the first step. They sent me something today, but it was during class, so I haven't looked at it yet.
You need to look at that as soon as
Yeah.
possible. It needs to have that done Wednesday.
Oh, and then For the actual class from 11:15 to 2:15, are TAs expected to show up during that period if they can?
That would be
or-
greatly appreciated because again, that's when the majority of our students are going to be around. So the more people we can have, the better. Something that we did last summer that worked out pretty well is every team kind of had their own breakout room and people could go to them as needed, and it worked out pretty well.
Yeah, I think for WebEx, I know there's a breakout room. I haven't like used that before, but I will figure out during the class. If
Cool.
yeah, if they want one-on-one help.
Sounds good. Anything else we can help you with at this time?
Ben, so can you add me to next fall class of Brightspace? Because I need to do the pre-lab.
Yes, I'll add you to that.
Yes. Yeah.
All right. Let me know if you guys have any other questions or concerns. Thank you again for your help this semester.
Okay, thank you. Ben, can you stay a little bit? I have a quick thing.
I'll be here.
Yeah, I think everyone else, you can leave if you want. Thank you. We will see you in tomorrow class.
Oh, actually, so for tomorrow's class, I'm not able to show up during the entire period because one of my classes goes until noon. I can show up after that, though. So, yeah.
Show up when you can.
Cool. Thank you.
You saw my email about I need to attend the conference next week, right?
Yep, I'll go
Yeah.
ahead and lead up the sessions.
Yeah, I received the schedule, so I will like have like for Monday meeting. I think I can hold like for like 20 minutes.
Okay.
Yeah, for the Tuesday class, I probably need you to cover it.
That's fine.
Yeah, then Thursday I will be fine.
Okay, sounds good. I'll cover the Tuesday one then. So that'll be lab 3. So doing
Yeah,
oscilloscope.
lab 3. Yeah, I will upload a video for the introduction before the class. So hopefully they will get the idea.
I can do that for lab 3. That's fine. So I'll
Okay,
do the
then-
little
then-
lecture there. So,
Okay, yeah, sure. Thank you.
Yep. All right. Have a good one, sir.
Yeah, bye. See you.